Okay, that's a good start for the joints method. Next, I want to do the section method. Okay, now I'm gonna start analyzing this truss using the section method. And again, I've got to be careful because it isn't a 45, 90 uh, truss. Okay, so for the section method, let's say just for the purposes of this exercise, that I'm really interested in finding out what um, J, K, and L are. If that's the case, I'm going to cut through J, K, and L, just like that. And I'm going to redraw. So I'm going to redraw this side of the truss. Mhm. Just redraw this cut line. And then highlight these numbers that are being cut. This is J, K, and L. Okay, so now what I'm going to do, I've got this side of the truss redrawn, and I always think it's easiest to avoid the diagonal member to start with. So let's try and find J and L before we try and find K. So let's think about L. Well, I need to find a point to rotate around that is going to give me L, but isn't going to give me K and J. And this point is going to be good for that. I forgot to number my points, so let me do that. 3, 1, 2, 3, 4, 5, 6. Okay, so I think 5 is going to be a good one to start with because J and K are touching 5, or they run straight through 5. So that means their moment around 5 is going to be 0. But L um, does not touch 5. So I can solve for just L by itself. So let's say the sum of the moments around point 5 equals 0. And I'm going to say counterclockwise is positive. And that is going to be, let's see what that's going to include. I know there's L, so I can say um, L. I'm just going to assume L is positive. I don't know what L is, but I'm just going to guess that it's positive. L times, and let's think about how far away is L from 0.5. Well, actually, I'm not sure because in the problem, it tells me that the spacing horizontally is 5 feet. It doesn't tell me what it is vertically, and that's what I need here. So I'm going to quickly redraw a triangle here. Say this is C, A, D. I'm just redrawing this part of the truss so I can solve for the lengths. This is 60. This is 30. Okay, so I know D is 5 feet. And I want to solve for A. So tangent is a useful trigonometric function here because it relates the horizontal component and the vertical component. So Soka Towa, tan is opposite over adjacent. So I can say, I can come in here and say tan of, I'm going to say tan 60 is equal to opposite over adjacent. So tan 60 is equal to opposite A over adjacent D. So A over D, and D is 5 feet. So I'm going to say times 5 feet times 5 feet. A is equal to tan 60 times 5 feet. Tan 60 times 5 feet. 8.66. And I can label that on my Truss here. 8.66 feet. Okay. So I can say, okay, the distance here is going to be 8.66 feet. Okay. What else is there? I'm not going to use K or J because they're touching 0.5. I'm not going to use any of the members on the inside of the truss here because they're not being cut. I am going to use these external forces. Am I going to use the 6 kips? No, because it's touching 0.5 or it's running through 0.5. So the moment would be 0. I'm going to use this 2 kips though because it's away from 0.5. So I can say plus 2 kips times, and it's the distance from 3 to 5, which is going to be 5 feet away. 5 feet. And I can say that's plus 2 kips because if we're rotating around 0.5, the 2 kips would be creating a counterclockwise rotation. So that's positive. There's also this 4 kips, so I can say plus 4 kips times, and that's going to be 3 to 5 and 1 to 3. So that's 5 plus 5 feet is 10 feet away from 0.5. And then there's also this reaction force. So plus RA, which is 15 kips times, well, if I extend RA, it's in the same spot as the 2 kips perpendicular to 0.5. So I can say that distance is going to be 5 feet. But the 15 kips is going in the opposite direction of the 2 kips. We already said that the 2 kips is positive, and the RA now will be creating a clockwise rotation around 0.5. So RA, that's going to be negative. So I'm going to say plus negative 15. All right. Are there any other forces? I don't think so. So now we can start solving. We can say times 8.66 feet plus 10 kip feet plus 40 kip feet minus 75 is equal to 0. Well, times 8.66 feet. And that's going to be plus 10 plus 40 is 50 minus 75. So it's going to be negative 20 minus 25 kip feet. I can add the 25 to both sides. and say L is going to be equal to 25 feet over 8.66. Okay, L is equal to 2.88, 2.9. So L is equal to 2.9 kips. Okay, I got a positive answer, which means that my assumption was correct, and I assumed that L was positive in the original equation. Positive moment means a counterclockwise rotation. So L must be creating a counterclockwise rotation around 0.5, which would be like this. So L must be pointed that way. So I can say, then that's away from its point, 0.6, but I can say that it's an intention.